Hello class, so today here in Statics of Rigid Bodies, we are going to discuss our lesson 5, which is about couples. So for this topic, our intended learning outcome is as follows. So students must be able to identify the concept of couples. So before we proceed to our discussion proper, you're going to answer this first. So this will be the question. Okay, referring to the figure here, if the side of each square is 1 meter, determine the first one is the moment at A, number 2 moment at B, number 3 moment at C, number 4 moment at D, number 5 moment at E of the forces that you can see in this system. Okay, so the first one to give the correct answers will receive the bonus point. So maximum of 2 points for each student. So you just have to comment your name, your section, the item of what you're answering, and your answer. And don't forget to include the unit of your answer. So I hope that you receive the bonus point. So let us define couples. So couple, they are two parallel, non-collinear forces that are equal in magnitude and opposite in direction. It is a special case in which the resultant has zero magnitude but does have a moment. This moment sum is constant and independent of the moment center. So we are going to discuss one by one these definitions. Okay, so the first definition here, a couple, okay, they are two parallel, okay, non-collinear, equal in magnitude, and opposite in direction. So these are the conditions that have to be met, okay, for you to say that two couples or two forces are couple. Okay, so the first one, it has to be parallel. Okay, the second one, it has to be non-collinear. Non-collinear meaning to say they are not located in one line of action. Okay, but they are parallel. They are non-collinear, but they are parallel. The third one, they have to be equal in magnitude. Okay, and the last one, they should be opposite in direction. So if one condition here is not met, okay, so those two forces are not a couple. Okay, so these four conditions should be met. Okay, so the second definition here, it is a special case in which the resultant has zero magnitude but does have a moment. So let's say you have two forces. Okay, so let's say that these two forces are, let's say, vertical forces. Okay, your first force, it is directed upward, and your second force, let's say, is directed downward. And let's say that these two forces are parallel, okay, and they are non-collinear. And let's say that they have the same magnitude, okay, and they are oppositely directed, right? So let's say that we are going to solve for its resultant. So if you are going to solve for its resultant, we are going to take the summation of the those vertical forces. Okay, so take note, they are opposite in direction and equal in magnitude. So if we sum them up, okay, if we take the summation of these vertical forces, it will give you zero, since they are equal in magnitude and opposite in direction. So the resultant will be zero. But since they are parallel, since they are non-collinear, since they are equal in magnitude and opposite in direction, okay, so this force system will produce a moment. Okay, and that moment is called the couple. Okay, so for a system of forces, okay, that are parallel, non-collinear, equal in magnitude and opposite in direction, its resultant will be zero, but there will be a moment. Okay, so that moment is the couple. Okay, so this is a special case that you have to remember. Okay, and the third definition here, this moment sum is constant and independent of the moment center. So meaning to say, even if you take the moment, okay, of these two forces at any point, it will give you the same answer. It will give you the same magnitude and direction of moment. Okay, so let's say we have here this two forces. Okay, so we have here this force F, and it is directed this way, and we have here this force F also. Okay, and these two forces are parallel. Okay, these two forces are also non-collinear, and these forces have the same magnitude. They are magnitude F. Okay, and also they are opposite in direction. Okay, so since it met, okay, all the conditions here for you to say that this is a couple, okay, so therefore this is actually a couple. Okay, so for this couple, okay, so to solve for its magnitude, for the magnitude of this couple. So again, a couple is a moment. Okay, so how you solve moment, okay, so the unit for moment, it will be the same unit, okay, for your couple. Okay, so your formula for couple is actually equal to F times D. So it will be equal to F times D, and your F will be the magnitude of your force. So since both of your forces are both F, okay, so it will be F, and the distance D, the D here is the distance, okay? It is the perpendicular distance, okay, between these two forces. Since they are parallel, they will really have a perpendicular distance, and that perpendicular distance D is the D here in this formula, okay? And that will determine, okay, the magnitude of that couple. Now for the direction of this couple, okay, it can be determined, okay, by the direction of its rotation. So in this case, let's say this force is directed this way and this force is directed this way. Okay, so it will rotate, okay, it will rotate in this direction, right? So this force F, it will rotate towards this force F this way, and this force F, okay, it will rotate this way towards this other force F, right? So it will create, what direction is this? It will create a counterclockwise, oh no, a clockwise direction. Okay, so this couple, okay, in this figure, okay, in this system, it will produce a clockwise couple or a clockwise moment, right? So that will be the direction for this. Now, we are going to prove that this third definition here, it says here that the sum moment or the moment sum or the moment or the couple is constant and independent of the moment center. So we will try to take the moment of these forces, okay, of this force F and this force F. They are a couple, right? So we will prove that if we take moment at different points, it should give the same magnitude and the same direction of moment. Okay, so we will try to prove this. So let's first take the moment, okay, of these forces about point A, about this point. So taking the moment about point A, okay, it will just be the summation of the forces, okay, that has or that have moment about point A. So we will assume that clockwise will be the positive rotation. So the moment at A, okay, it will just be since this force, okay, it passes through point A, it will be cancelled, right? It will have no moment, okay, about point A. But this force, so this force, it will have a moment about point A and it will rotate this way, okay, and its moment will be F times its perpendicular distance from point A, that will be distance D. So its magnitude will be F times D. Okay, and its rotation will be clockwise about point A, so it will be positive here. So this will be the moment of these forces, okay, of this couple about point A. This is F times D, and this is clockwise. Okay, and as you can notice, it is really clockwise, right? This couple is clockwise. So also in your moment, when you are taking moment, okay, it will be the same direction. Okay, it will also rotate in a clockwise direction. Okay, so the second one, okay, we will go to summing up the moment at point B. Okay, so supposed to be, okay, so your moment at B, okay, of these forces, since these are couple, okay, so it has to give the same magnitude and direction of moment, okay, of these forces. So let's check if this will produce the same magnitude and direction of moment. So let's take moment at B. So it will just be the summation of all the forces that have moment at point B. Okay, so we know that these two forces will have a moment, right, at point B, since there's no force here that passed through point B. So let's say we take the moment of this force, of the farther force here. So it will just be F, and its moment arm will be D plus A, right? It will be the moment arm of this force. So it will be F times D plus A. So that will be the moment of F, force F here about point B. And it will be clockwise. That's why it will be positive here. Now, this force, okay, it will also have a moment about point B. Okay, so it will have F times its moment arm, which will be A. Okay, so that will be F times A. Now, its direction will be counterclockwise about point B. So it will give you negative here. So simplifying this, okay, so this will become F times E plus F times A minus F times A. So FA, okay, will be canceled here. Okay, and what will remain here is just FD. And this is positive, meaning to say the direction of the moment at B of these forces will be clockwise. Okay, so from here we can say that the moment remains unchanged, right? So it has the same moment effect. These two forces, which is a couple, okay, they have the same moment effect regardless of the moment of center. So let's try to prove this further, no? So let's say we take the moment at point C. So supposedly it should give us the same magnitude and direction of moment, no? So it should be FD and it should be clockwise. So let's check if it will give that answer if we take moment at point C. So taking up moment at point C, it will just be the summation of all the forces that have moment at point C. Clockwise will be the positive assumption of rotation. Okay, so it will just be, since this force will pass through point C, it will be cancelled. No, it will have no moment effect about point C. Okay, but this force, okay, it will have a moment effect about point C. So it will have this moment F times its perpendicular distance D. So that will be FD, and its rotation will be, or direction of rotation about point C will be clockwise. That's why it will be positive here. So we can prove, okay, from these answers, okay, that the moment, okay, or the couple, okay, the moment of the couple, okay, its direction and its magnitude, okay, it will be constant. Okay, and it will be independent of the moment center. It will have the same effect, moment effect at any point. Okay, so this is an important concept about couple. Okay, so as you can see also in the pre-assessment that you answered, okay, so we know that those two forces are couple, and as we computed that, okay, at any point it will give you the same moment effect, right? It will give you the same direction of moment. It will give you the same magnitude of moment because that is the concept for couple. So again, these are important concepts about couple. It should be, again, it should be parallel, non-collinear, equal in magnitude, and opposite in direction. And also, it is a special case that their resultant force is zero, but has a moment. Okay, the resultant will be a moment. Okay, and the moment sum is constant in and independent of the moment center. So you have to remember, okay, and understand this concept because it will be a great help, okay, while we are solving systems with couples, okay, or if the system is actually a couple, okay, it will be useful. Okay, so again, the couple C is equal to FD, okay, and it will uh, FD has the same, or the couple C, which is equal to FD, has the same moment effect at any point. So that is an important concept about couple. Okay, so let's proceed. Now, let's try to solve problem here. So the first sample problem here is determine the resultant of the parallel forces shown below. Determine also the moments at A, B, C, D, and E. Okay, so this is actually about couples, no, this sample problem. But we will see, okay, so how the concept of couple applies here in this problem. Okay, so let's try to solve this. Okay, so let us solve this. Okay, so again, we are asked here to find for the resultant of this system. Okay, and we are also asked to solve for the moment at A, moment at B, moment at C, moment at D, and moment at E. Okay, so let's solve this. So let's first solve for the resultant. So to solve for the resultant, okay, it will just be the summation, okay, of the vertical forces. Okay, so positive will be the positive, will be the, I mean, upward will be the positive assumption here. Okay, so it will be negative 10 since this is directed downward, and we have here 20 newton. It will be plus here since this is upward, and 30 newton, it will also be positive here since this is the upward, no? And also we have here 40 newton, and it will be negative here since it is directed downward. Okay, so from here we can say that the resultant is 0. So as we solve that, negative 10 plus 20 plus 30 minus 40, it will be 0. So the resultant here is 0. Okay, so that will be the answer for the resultant. Okay, so now we are also asked to solve for the moments at A. Okay, B, C, D, and E. So let's first solve the moment at A. So solving for the moment at A, it will just be equal to the summation of all the forces that have a moment at A. So this will be point A. Okay, clockwise will be the positive assumption. Okay, so the first force here is 10 Newton, and it will have a clockwise rotation about point A, and it will have 2-meter moment arm. So this will be 10 times 2, and since it is clockwise, it will be positive here. Now for your 20 Newton, it will have a moment of 20 times 3 plus 2, right? So that will be 5. The moment arm will be 5, and its rotation about point A will be counterclockwise. That's why it will be negative here. Now, for your 30 Newton force, it will have a moment of 30 times its moment arm. So its moment arm will be 1 plus 3 plus 2. So that will be 6 meters. So that will be 30 times 6. And it will have a counterclockwise rotation about point A. That's why it will be negative here. Okay, and also for your 40 Newton force, it will have a moment of 40 Newton times its moment arm. So its moment arm will be 2 plus 1 plus 3 plus 2. So that will be 8 meters. So its rotation will be counterclockwise, or clockwise rather, clockwise about point A. So it will be positive here. So solving for that moment, for the magnitude of that moment, it will be 60 Newton meter. And since the answer is positive, meaning to say the moment is clockwise. Oh, so this will be the moment at point A. Now, we will go now to the moment at B. Okay, so solving for the moment at B, it will just be the summation of all the forces that have moment at B. So our assumption here will be clockwise for positive. Okay, so for point B, so this is where our point B, okay, is located. Okay, it's here. Okay, so meaning to say this 2 Newton force will be cancelled, right? Or it will not have, okay, moment effect about point B since it passes through point B. Okay, so let's start with 20 Newton. So its moment will be 20 times 3. Okay, so that's why it's 20 times 3 here, and its rotation will be counterclockwise, right? That's why it will be negative here. Now, for your 30 Newton force, it will have a moment of 30 times its moment arm, which is 1 plus 3, so that will be 4, and its rotation will be counterclockwise. That's why it will be negative here. Now, for your 40 Newton force here, okay, so uh, here at point B, okay, it will have a moment of it will have 40 times its moment arm, 2 plus 1 plus 3, so that will be 6 meters, and it will have a clockwise rotation about point B, so that's why it's positive here. Okay, so from here, okay, so we can solve that the moment at B is 60 Newton meter. So since it's positive, it also has a clockwise rotation. Oh, so this will be the moment at B. So from here, we can actually draw a conclusion from here, right? So since we can see that our resultant is equal to 0 and our moment at A and moment at B, okay, so they are equal. So tentatively, we can say that our force system is actually a couple. Okay, so they can be deduced, okay, into a couple. Okay, but we still have to check, okay, we still have to check the moments, the remaining moments, okay, moments at C, D, and E. So it has to be 60 Newton meter clockwise as well, so that we can conclude that this force system is a couple. Okay, so again, let's proceed now to the moment at C. So for moment at C, okay, it will be just summation of all the forces that have moment at C. So all the forces that have moment at C will be 10 Newton, 30 Newton, and 40 Newton. And this 20 Newton force will will not have a moment, okay, about point C because it passes through point C. Okay, so let's start summing up. So let's start with 10 Newton. So 10 Newton force will have a moment of 10 times 3 meter. So that will be 10 times 3. And it will have clockwise or counterclockwise rotation about point C. That's why it will be negative here. Okay, now for 30 Newton force, it will have a moment of 30 times 1. Okay, and it will have a rotation of counterclockwise. That's why it will be negative here. Now for 40 Newton force, it will have a moment of 40 times its moment arm will be 3 meter. Okay, at point C. Okay, so that will be 40 times 3 and its rotation will be clockwise. That's why it will be positive here. So solving this, it will also give you 60 Newton meter and this is also positive, meaning to say it is clockwise. Okay, so from here, okay, we will proceed to the next moment. That will be moment at D. So again, we will sum up all the forces that have moment at D and it will give you the following moments. It will be negative 10 times 4 plus 20 times 1 plus 40 times 2 and it will also give you 60 Newton meter clockwise moment. Okay, and lastly, for your moment at E, okay, if we sum up all the moments or all the forces that have moment at E, okay, it will just be negative 10 times 6 plus 20 times 3 plus 30 times 2. So it will give you 60 Newton meter force and this is positive. So this will also be clockwise. So from here, okay, so we have confirmed here, class, that our force system, okay, since its resultant force is 0, okay, but there's a moment, okay, in every point and has the equal moment in every point. Okay, so meaning to say, we can conclude that this force system is actually a couple. So actually, if we observe our force system, okay, if we look at the forces involved here, so let's say these two downward forces, we have here 10 Newton and 40 Newton, they are downward. Actually, if we solve for the resultant of these two downward forces, it will be 50 Newton downward, right? And if you notice here also, the upward forces are 20 Newton and 30 Newton. If we solve for the resultant, okay, of these two upward forces, it will also be 50 Newton. Okay, so meaning to say, if we redraw it this way, okay, so this will be the resultant of these two downward forces, 50 Newton, and this will be the resultant of these two upward forces, which is also 50 Newton. So from here, okay, we can figure out, okay, that this system is really a couple. Okay, since we have here two forces, this 50 Newton and 50 Newton, we have two forces here that are parallel. They are non-collinear. Okay, they are opposite in direction and they are equal in magnitude. So therefore, this system is really a couple. So again, a system that has zero resultant force but has a moment. Okay, so that is a couple system. Okay, so the resultant here will be a moment. Okay, will be a couple. Okay, zero yung resultant force, but the couple or the moment has a value. Okay, so this is a concept, okay, again for couple. Okay, so from our computations, okay, again we have come up to that conclusion that our force system is a couple. Okay, so again, this is a special case, okay, wherein the resultant is zero, but there is a moment. So meaning to say, your system is a couple. The resultant of that system is not a force. Okay, so there will be no resultant force, but there will be a resultant couple or resultant moment. Okay, so from here, we can actually add a question here. Okay, so we can also solve, okay, the distance d of the couple. Since we have already known that this is a couple, okay, so there's actually a distance d, okay, between these two forces, 50 Newton and 50 Newton. Okay, these are the forces that make up this couple. Okay, so we can solve for the distance d between them. Okay, so again, your couple here will be equal to all the moments. Okay, since all the moments here are all equal, okay, it will be the magnitude and direction of your moment. Okay, and the formula for your couple, it will be equal to F times D. Okay, we already know the magnitude and direction of our couple, okay? And our force F, our force of F here will be 50 Newton. Okay, so these two forces are equal and they are both 50 Newton, and that will be the value for F, 50 Newton, and the distance D, that is the unknown. So substituting here 60, so this is 60 Newton meter is equal to our F here is 50 Newton times distance D. So solving for distance D, it will just be 60 divided by 50, it will be 1.2 meter. So this will be the distance D, okay, of the two couples. Okay, so also from this drawing, okay, of this system, we can actually redraw, okay, our system into a couple system like this. Okay, so this system, okay, this couple system is actually equivalent to this system. Okay, so we can redraw it this way. Okay, so we can redraw our force system. Okay, if its resultant is 0 and the resultant is a couple, okay, we can redraw it this way. So these are two equivalent system. Okay, so our second sample problem here, we have to determine the resultant moment about A of the system of forces shown below. Each square is 1 meter on a side. Okay, so from here, okay, so this is a force system, okay, and if we are going to analyze, okay, and inspect the forces involved here, we have here 100 Newton force, we have here 200 Newton force, we have here 80 Newton force, they are actually 280 Newton force, and we have here two 100 Newton forces. Okay, and if you are going to analyze this, okay, you can notice here, okay, that we have here 80 Newton, and they are two forces. No, they are two forces that are equal in magnitude. They are both 80 Newton, and they are directed in the opposite directions, right? And also they are parallel and they are non-collinear. So from here we can actually say that these 280 Newton forces are a couple, okay, or is a couple. Okay, so if we know the concept of a couple, okay, we know that its moment, okay, its moment, the moment of these two forces will be the same at any point, right? Okay, and also class, you can also notice here this 100 Newton force, these two 100 Newton forces, okay, we can say that they are parallel forces, right? They are opposite also in direction, and they are also equal in magnitude, and they are non-collinear. So we can also say that this 100 Newton forces is a couple, right? So, since we know that they are a couple, okay, we can say that its moment effect at any point will also be the same. Okay, as long as we know the formula for couple. So the formula for couple is F times D, right? So, from here, let's start solving. Okay, so let's answer this. So again, we are asked here to solve for the moment, okay, about point A, okay, of all these forces in the system. Okay, so again, to solve this, okay, for moment at A, okay, so again, if we analyze the forces involved in this system, okay, we can notice here, okay, that there are forces that are a couple. Okay, so from the example 1, okay, our system, okay, the resultant of our system is a couple. Okay, but here in this system, okay, we have here um, components, okay, that are couple. Okay, so from here, okay, we can notice that these 280 Newton forces, okay, they are a couple, right? Because, okay, they satisfy the conditions because they are parallel, they are non-collinear, they are both 80 Newton, meaning to say they have equal magnitude, and they are oppositely directed. Okay, so for this two forces, okay, if we're going to solve for the magnitude of this couple, it will just be F times D. That will just be 80 Newton and the distance between them, the perpendicular distance between them, which is just 2 meters. So 2 meters will be the distance between these two forces, okay, in this couple. So its magnitude, okay, the magnitude of this couple will just be F times D. And from that, okay, so again, a couple is a moment. So if we sum up or take summation of moments, okay, in this, in point A, about point A in this system, okay, we can directly include, okay, the moment effect of these two forces, which is a couple. Okay, so instead of solving for the moment of these 280 Newton forces individually about point A, okay, we can use the concept of a couple, okay, that it's a moment, and regardless of the center of moment, okay, or moment center, okay, it will have the same magnitude and direction. It will have the same moment effect. Okay, so this couple, okay, we can directly include it in our summation for moment about point A. Okay, so the concept for couple will be useful here. Okay, that we don't need to solve for the moment of these two forces individually. Okay, we can just solve its couple, okay, or the magnitude of this of its couple and the direction, and just sum up or include them directly in the summation of moment. Okay, so it will be the same here for these two 100 Newton forces. These are also a couple, right? These forces are also a couple because they are parallel, they are non-collinear, they are same in magnitude since they are both 100 Newton, and they are oppositely directed, meaning to say they are a couple. Okay, and from that, okay, we can solve the magnitude of this couple. Okay, so we just have to determine, okay, their parallel distance or the distance between them, the perpendicular distance between them rather. No, so the perpendicular distance between them will be this. Okay, and as we can see here, this is actually a triangle, right? And this side will be the hypotenuse side of the triangle. Okay, and the other sides are 1 meter, both 1 meter, right? So using Pythagorean theorem, that will just be square root of 1 squared plus 1 squared to solve for the hypotenuse. So that will be square root of 2. So this square root of 2 will be the perpendicular distance of these two forces, okay, in this couple. Okay, and also we also have to determine the direction of these two couples. Okay, so we can rewrite them or redraw them, okay, in this system. Okay, so as we can see here, the direction of this couple, okay, the direction of their rotation, they will rotate this way, right? And this is clockwise. Okay, so that's why that couple will be clockwise. Okay, and we name it here as C1. Okay, so also the second couple here, okay, it will rotate meanwhile this way, right? So this will be counterclockwise. Okay, so that's why it will be counterclockwise couple here, and we name this C2. Okay, so from here, class, we can now start summing up moment, okay, about point A. Okay, so here, there are also forces here that we have to take their moment about point A. So for 100 Newton force, we can put the components here using principle of transmissibility, right? So we put the components here so that this vertical component, okay, will be or will pass through point A, and it will just be canceled. It will have no moment effect about point A. So only this horizontal component will have a moment effect about point A. And for this 200 Newton force, okay, so even if we put our component here or here, okay, both of the components will have a moment about point A. So we will put our components here. Okay, so let's start solving the moment about point A. So again, it will just be the summation of all the moments about point A, and clockwise will be the positive assumption. So let's start with the horizontal component of this 100 Newton force. So the horizontal component of this 100 Newton force, so from the slope triangle, it will have run of 1 and a rise of 2. So the hypotenuse of the slope triangles will just be square root of 2 squared plus 1 squared. That is square root of 5. And from that, we can solve for the horizontal component of this 100 Newton force. So that will just be 100 times the side in the slope triangle that is parallel to the component we are solving, which is horizontal. No? So that will just be 100 times the horizontal side, which is 1, over the hypotenuse, which is square root of 5. That will be the horizontal component. Now, the moment arm of that horizontal component, okay, if we take the moment about point A, it will be 1, 2, 3, 4. That's why it will be 4 here. And its rotation about point A will be counterclockwise. That's why it will be negative here. Now, for your 200 Newton force here, so we solve for the horizontal and vertical components here. Okay, their moment. Okay, so let's first solve for the horizontal component. So its horizontal component will just be 200 times the side in the slope triangle that is parallel to that component, which is 3. So that will be 200 times 3 over square root of 13. Okay, and its moment arm will be 1, 2, 3. Okay, so that will be 3, and its rotation will be clockwise about point A. Okay, so that will be positive here. Now, for the vertical component, it will just be 200 times the side in the slope triangle that is parallel to that component, that is 2. So that will be 2 over square root of 13, and its moment arm about point A will be 1, 2. So its rotation will be clockwise. That's why it will be positive here. And also, okay, so again, instead of taking up the moment, okay, of the forces in your couple individually about point A, we can directly include, okay, in our summation the magnitude, okay, or the value of the couple. Okay, so for your first couple, so your first couple is actually clockwise. So your sign convention, our sign convention here is for clockwise, it will be positive. That's why it will be positive here. Now for our second couple here, we know that it is its direction is counterclockwise. So from our sign convention, it will be negative here. Okay, so again, our C1, okay, our C1 will be F times D. So that will be 80 times 2. Okay, so 80 times the perpendicular distance between these two forces, which is 2. And this is positive nga since it is clockwise, right? And now for your second couple, okay, so this will be F times D also. That will be 100 times their perpendicular distance, which is square root of 2. And this will have a counterclockwise rotation. That's why it will be negative here. So from here, okay, solving this, so let's input this in our calculator. This will be 100 times 1 over square root of 5 times 4 plus 200 times 3 over square root of 13 times 3 plus 200 times 2 over square root of 13 times 2 plus 80 times 2 minus 100 times square root of 2. So that will give you 560.80 Newton meter. So don't forget, okay, the unit for this. Okay, so our unit here is Newton meter. Okay, so this will be the answer, okay, for this problem. So as you can see here, okay, so um, the concept, okay, of couple will be useful here. Okay, since we don't need to take up the moment or to solve for the moment of these forces individually, right? Because we know that they are a couple. So we just directly include them in our summation for moment since couple is a moment. Okay, so this will be the answer for this problem. So let's proceed to sample problem number 3. The cantilever truss shown carries a vertical load of 2,400 Newton. So this is the 2,400 Newton load. So the truss is supported by bearings at A, okay, and B, which exert the forces AV, AH, and BH. So the four constitute two couples which must have opposite moment effects to prevent movement of the truss. Determine the magnitude of the supporting forces. So again, we have here a truss, okay, and we have here a force, okay, a load, which is 2,400 Newton, and we have here three reaction forces, okay, we have your AV, AH, and BH. So these four forces, okay, that are involved in our system, it says in the problem that they will constitute or produce two couples. Okay, so these two couples, okay, they should be opposite in moment effects. Okay, so that the truss, okay, will remain stable. Okay, so let's say for this 2,400 Newton force and for AV, let's say they will produce a couple. Okay, so this will produce a counterclockwise moment effect, right? So, meaning to say the other couple that will be produced, it should produce a moment that is opposite in direction, okay, to the first couple that was produced. Okay, so if the first couple produced a counterclockwise rotation or moment effect, this second couple, it should constitute or produce clockwise, no? And the couple in the first or the magnitude of the couple in the first couple produced, it should be the same to the magnitude of the second couple. So we will start solving this. Okay, so again, we are asked here to solve for the value of forces AV, AH, and BH. Okay, so let's start solving this. So again, um, these four forces, okay, so these four forces, this 2,400 Newton, AV, AH, and BH, they will produce two couples. Okay, so for the first couple, it will be produced by this 2,400 Newton force and AV. But to say that they are a couple, they have to satisfy the conditions that they should be parallel. So that will be checked for that condition. They are parallel, right? And also they are non-collinear. So they are checked for that condition. And they are also opposite in direction, right? So they are also checked for that condition. And okay, the last condition should be they should be um, equal in magnitude. So for these two forces to produce a couple, okay, so this AV should also be equal to 2,400 Newton. So by observation, okay, from this figure, we can say that your AV is equal to 2,400 Newton. So that will be the magnitude of your 2,000 of your AV. Again, that is equal to 2,400 Newton. Now, the couple that will be produced by 2,400 Newton force and AV, which is also equal to 2,400 force, or 2,400 Newton, it will just be equal to F times D. So your F will be 2,400, and your distance D here will be 6 meters. Okay, and the rotation of this couple, okay, it will be counterclockwise, right? It will be counterclockwise. That's why it will be negative 2,400 times 6 here. So this will be the value of the couple, negative 14,400. And its unit, again, it's the same for the unit of moment, that it will be Newton meter, since the force here is Newton and the distance here is meter, no? So that will be the value, okay, or the magnitude and the direction of the couple. So the second couple, okay, it should be also equal in the magnitude of this first couple, but opposite in direction. Okay, so to solve that, okay, we are going to use what we have solved for the value of C1, okay, in solving for the second couple that is produced. So as mentioned in the problem, those two couples will have equal magnitude, right? So we can say that this couple, okay, to prevent moment of the truss, yun nga, your couple, one, or your first couple, it must be equal in magnitude to the second couple, produced by BH and AH, but should be opposite in direction. So, if the couple produced in your first couple, okay, if the direction is counterclockwise, your BH and AH, the moment that, or the couple that should be produced should be clockwise. So, as we can see here, since the direction of BH is rightwards and the direction of AH is leftwards, so it will really produce clockwise couple, right? So, from the first couple that we have, so we are going to use the magnitude, which is 14,400, and we can equate that, okay, to our second couple. Okay, so that will be 14,400 is equal to, your F here will be either BH or AH, since they are equal in magnitude, right? Your BH and AH, times their perpendicular distance D, which is 4 meters. So that will be 4. And therefore, we can solve for BH. So that will just be 14,400 divided by 4, which will be 3,600 Newton, no? So your BH and AH will be 3,600 Newton. Okay, so this will now be the answer for BH. Your BH is 3,600 Newton rightwards, and your AH will be 3,600 Newton leftward. So these will be the answers for this problem. No, your AB is 2,400 Newton, your BH is 3,600 Newton, and your AH is 3,600 Newton as well. Okay. So now let's proceed to the resolution of a force into a force and a couple. So it is sometimes necessary to replace a force acting at a given point by an equal force acting through some other point. This introduces a couple. So let's say we have here a force F, okay, here in our figure A. Okay, so let's say we have here force F and it is applied at point A. So if we want to have an equivalent system wherein your force F will be transferred at point B, okay, so what we're going to do, if we're going to transfer your force F here at point B, okay, in order that this system will not be changed, okay, we have to add here a force F also, okay, that is opposite, okay, in direction, okay, opposite in direction of this force F also, and it should be collinear. Okay, so that's our rule. If we want to transfer our force F in, let's say, point B, we had to add up here a force that is equal in magnitude to this force, a force that is opposite in direction to the direction of this force, and it should be collinear. Okay, so that will be our rule so that the system will not be changed. Okay, so from here, we can notice here that this force F, okay, the force that we added, okay, and the force, our original force F here, it will actually produce a couple, right? So this produce couple, okay, we can rewrite it this way. Okay, so meaning to say, if we transfer, okay, this force F to from point A to point B, okay, let's say we put our force F here, it will produce a couple. And this system, okay, this force and couple system, okay, it is actually equivalent to this original force system. Okay, they are equivalent. Okay, so again, the force couple system, which is here in figure C, this is an equivalent, okay, force couple system, okay, of the force system in figure B and figure C. Okay, so this will be the resolution of a force, okay, into a force and a couple. So let's solve sample problem number 1. A short compression member carries a centric load P, which is equal to 200 Newton, and it is situated 0.2 meter from the axis of the member. Determine the equivalent axial load and a couple that is applied at the axis of the member. So the problem here is that our force P here, okay, our load, eccentric load here, okay, so this load is not applied in the axis, okay, of this is a member. Okay, so this is a compression member. So this is not applied to the center, okay, to the center or to the axis, okay, of the member. So it is situated, okay, 0.2 meter from the center or from the axis of this member, no? So our problem here is we have to determine, okay, the equivalent force and couple system, okay, that this force P, okay, we are going to transfer it, we should transfer it at the axis of the member. So therefore, it will produce a couple, right? As we have mentioned from our introduction, that if you transfer a force from a specific point to another point, it will produce a couple, okay, in order for that system to be an equivalent, okay, to the original system. Okay, so let's solve this. Okay, so we are going to find, okay, the equivalent axial load and a couple that is applied at the axis of the member. So we want to transfer, okay, the original force or load which is located 0.2 meter from the axis, we want to transfer that at the axis or at this axis, no? So, in order to do that, okay, to produce an equivalent system, okay, so if we transfer 200 newton at the axis, okay, so since we transfer it, we have to add here, okay, a force that is opposite in direction, that is collinear, and has the same magnitude as the force that you have transferred, no? So we will add this force, this upward force, which is also 200 Newton force, and this is collinear to the force that we transferred. Okay, so from here, okay, we can notice that there will be a produced couple. So the produced couple will be this 200 Newton and this 200 Newton, right? So it will produce a clockwise couple, right? So from here, we can redraw it that these two forces, okay, this will produce this couple, this clockwise couple. Okay, so the magnitude, okay, of this produced couple will just be F times D. So our F here will be 200 Newton, and our perpendicular distance D here will be 0.2. So this will be 200 times 0.2, and it will be 40 Newton meter. Okay, so we can draw, okay, this couple in our system this way. So this is clockwise, and this is 40 Newton meter. So this will be the system, okay, the equivalent force and couple system that we are looking for this problem. So this drawing is actually the answer for this problem. Okay, so again, if we are going to transfer this 200 Newton force to our to the axis, okay, so it will produce a couple. So this will be the equivalent force and couple system of this original force system. So these are equivalent, okay? Okay, so let's proceed to sample problem number 2. Replace the system of forces acting on the frame by a resultant R at A and a couple acting horizontally through B and C. Okay, so we have here a force system. Okay, so we have here forces 20 Newton, 30 Newton, and 60 Newton. Okay, so we can solve for the resultant of this system, right? Okay, so what we are going to do here is replace that system. Okay, we're in the resultant. Okay, we're in the resultant in that new system. Okay, will be at point A. Okay, so here, our resultant will be on a different position. Okay, it will not be at point A. Okay, so it will be at different position, and we have to replace this system into a new system where the resultant is located at point A. So meaning to say, we have to transfer, okay, the resultant that we will get, okay, that we will solve from this system, okay, and its position, no? So we will solve that, and we will transfer our resultant R at point A. So upon transferring that, it will produce a couple. Now, the produced couple, okay, so in the system that we are asked here, okay, we have to make that couple, okay, acting horizontally through B and C, through this B, no, and through C horizontally. So from that couple, they have to be resolved, okay, into forces, okay, that will produce couple. Okay, so that's the problem here. Okay, so again, we are going to replace this system into a resulta or into a system where the resultant is at point A. So we will transfer the location, okay, of your resultant, and it will produce a couple. Now, the couple that will be produced, okay, we will resolve that into forces acting at B and C horizontally in such a way that they will produce a couple. Okay, so let's start solving this. So let's start solving this. So again, we are asked here to find the equivalent force system wherein the resultant is at point A, okay, and a couple acting horizontally through B and C. Okay, so we will first solve for the resultant. Okay, so solving for the resultant, since these are vertical forces, it will just be summation of all these vertical forces. So we have this assumption that all forces upward will be positive. Okay, so this will be your 20 Newton force will be negative since this is downward, and then your 30 Newton force, it will be positive here since it is upward, and 60 Newton force will be negative here since it is downward here. Okay, so solving this will be negative 20 plus 30 minus 60. So your Ry will be negative 50 Newton. Okay, so that negative side, sign rather, it indicates that our resultant, okay, or your Ry is downward. Okay, so your resultant here will be 50 Newton downward. Okay, so from here, okay, we can assume, okay, that our resultant, which is 50 Newton downward, okay, is located somewhere here. Okay, so it will be our assumption it should be near 60 Newton because this is the largest load, right? Or largest force involved here. So it will be located somewhere near that force, no? So we will assume that it is located somewhere here. So this will be distance B from point A. Okay, so we have to solve for this distance B because we are going to transfer this resultant, okay, to point A. So upon transferring this 50 Newton resultant at point A, it will produce a couple. Okay, and the couple produce, okay, we will need this distance B. So we have to solve for this distance B. Okay, so we can solve this using Varignon's theorem. So applying Varignon's theorem, we can sum up a moment, okay, at point A. We can solve for the moment at A, okay, and that moment at A, it will be equivalent to the moment of this resultant, okay, of this resultant about point A, and it will also be equivalent to the moment of these component forces, okay, these component forces, okay, its moment about point A. So let's start solving this. So we will take the moment of R, okay, of our resultant R about point A. So that will be 50 and its moment R will be D. So it will have clockwise rotation about point A, right? So it will be positive here. Now for the moment of the component forces 20 Newton, 30 Newton, 60 Newton. So let's take the moment of 20 Newton about point A. So it will have a moment of 20 times 1, okay? And it will have a rotation of counterclockwise, okay? That's why it will be negative here. Now, for your 30 Newton force, since it will pass through point A, there will be no moment effect, okay, of 30 Newton about point A. So now for 60 Newton force, so this will have a moment of 60 Newton times the moment arm, which will be 4 meters. Okay, so that will be 60 times 4, and its rotation about point A will be clockwise, right? That's why it will be positive here. Now, solving for D, this will be negative 20 times 1 plus 60 times 4 divided by 50. So that will be 4.4 meters. So that will be our distance D. Okay, that will be 4.4 meter. Okay, so from the distance D that we have solved, okay, we can see here that our assumption is wrong. Okay, so our resultant is actually located, okay, a little bit more farther than this 4 meter, no? So it will be located somewhere here. Okay, so this will be 4.4 meter. No, so this will be the location and position of our resultant, which is 50 Newton. Okay, so from here, what we're going to do here is transfer this 50 Newton resultant at point A. So if we transfer this here, okay, to maintain our system, okay, we have to add here a force that has equal magnitude as the resultant, okay, and opposite direction, and it should be collinear. So we will add this 50 Newton force upward. No, so from here, this 50 Newton force upward and this 50 Newton force or resultant that is downward, it will constitute or produce a couple. Okay, so from that, okay, the couple that will be produced will be F times D. So the F is 50 Newton. Okay, since they should be equal, right? So they are both 50 Newton, and their distance, okay, perpendicular distance between them, that will be 4.4. Okay, so from here, okay, we can solve for the couple, and that will be 220 Newton meter. So the rotation of this couple will be this way. So this will be clockwise, right? That's why it will be positive here. So that will be the couple. Okay, so that will be the couple that will be produced. Okay, so we can redraw this system. Okay, we can redraw this system. Okay, this system this way. No, so our resultant here is already at point A. Okay, and we have now a couple here of 220 Newton meter clockwise. Okay, but the problem here, class, we are asked here that this couple should act horizontally through B and C. So we have to add forces here, class, that will produce the same direction and magnitude of couple, of this couple. Okay, so we can draw these forces this way. Okay, since we need clockwise. Okay, we need clockwise moment here. Your BH and CH should be. So again, we your BH and CH should be directed, okay, in such a way that they will produce a clockwise moment or couple. No, so your BH should be directed to the right, okay, and your CH should be directed to the left. This will produce, okay, a clockwise couple, no, which is that's what we need here. Okay, so from that, okay, so since we have here the magnitude, okay, of the couple, which is 220 Newton meter, and these two forces, they should be equal to produce a couple, right? And they have here perpendicular distance, which is 2 meters. So from that, we can solve for the value of BH and CH. So solving for BH or CH, we can use the solved couple. Okay, so our couple will be equal to either BH or CH. Since they are equal, okay, so we can use BH or CH times their perpendicular distance, okay, which is 2 meters. Okay, so that will be 2 meters. Okay, and our C here will be 220. Okay, so let's say we use BH. Okay, so this will be 220 is equal to BH times 2. Okay, so solving for BH, it will give you 110 Newton. Okay, so if BH is 110 Newton, our AH will also be 110 Newton. Okay, so this will be the value, okay, of BH and AH, and this will be the answers. Okay, so the answers will be the values of BH and AH. Okay, this result the answer for resultant and also this system. So this will be the answers for this problem. Okay, so again, this system, okay, is an equivalent system of this original system. Okay, so they are equivalent systems. For sample problem number 3, the four forces shown act on the rollers of an inline skate. Determine the equivalent force and a couple systems with the force acting at O. So point O is at the ankle joint of the skater. Okay, so we have here four forces. Okay, so these forces, okay, they are all vertical forces, no? So from these forces, okay, we can actually solve the resultant, right, or its equivalent force. Okay, the equivalent force of these four forces, okay, that will be the resultant. So after solving the resultant, we are asked here to determine, okay, the equivalent force and couple system wherein that equivalent force is located, okay, at point O. So after solving the resultant here, we are going to transfer that at point O. So upon transferring that resultant or equivalent force at point O, it will produce a couple. So we will solve that equivalent force and couple system. Okay, so let's start solving this. Okay, so again, we are asked here to solve for the equivalent force couple system with the force or the resultant acting at point O. So again, this is our force system. We have here four forces. So we will first solve for the resultant of these four forces. Okay, so to solve for the resultant, we will just sum up all these vertical forces. So it will be Ry is equal to the summation of all the vertical forces, wherein our assumption here will be upward forces will be positive. Okay, so this will be Ry is equal to 18 plus 30 plus 46 plus 60. So they will all be positive here since they are all upward forces. Now, that will be the value of our Ry, which is also equal to our resultant. So our resultant will be 154 pound upward. No, so Now, we can say that our resultant, okay, is 154 pound, and we will assume that it is located somewhere here. Okay, so we need to transfer this resultant R, okay, as mentioned in the problem, we have to transfer this at point O. It has to act, okay, at point O. So there will be a distance D, okay, if we transfer this resultant R to point O, this will be distance D. Okay, so to solve for this distance D, okay, we can use Varignon's theorem, okay, to solve for that. Okay, so this will just be the moment of this resultant, okay, at point O will just be equal to the moment of the component forces 18 pound, 30 pound, 46 pound, 60 pound at point O or about point O. So we will sum up their moments about point O. So let's start solving this. So we will take moment at O. So that will be the moment of this resultant R about point O. So that will be R times D. Okay, so our moment for that, our resultant is 154 and its moment arm will be D. Okay, so this will be 154 times D and it will have a clockwise rotation about point O. That's why it will be positive here. Now, for the component forces, which are 18 pound, 30 pound, 46 pound, and 60 pound, we will take their moment also about point O also. So let's start with 18 pound. So your 18 pound, it's its moment arm about point O will be let's say 3.5 plus 4.5 plus 3.5 minus 3.2 so that we can solve this perpendicular distance, right? So that again that will be 3.5. Okay, that will be 3.5, this 3.5 plus 4.5, okay, plus 4.5 plus 3.5. Okay, minus this 3.2 so that we can get this distance D. Okay, that will be the moment arm of 18 pounds. So that will be 8.3. Okay, that's why it will be 8.3 here. And its rotation about point O will be clockwise, right? So that this will be positive here. Now, for the 30-pound force here, okay, let's take its moment about point O. So we have to solve for the moment arm. So its moment arm will just be 4.5 plus 3.5 minus 3.2 so that we can get this distance, no? This will be the moment arm of 30 pound. Again, that is 4.5, 4.5 plus 3.5, okay, minus 3.2. Okay, so that will be 4.8. So that will be the moment arm of your 30 pound here. And its rotation about point A will also be clockwise. That's why it will be positive here. Now for 46 pound force, this force, so solving for its moment arm or moment, no, so we have to solve for the moment arm. So its moment arm will just be 3.5 minus 3.2 so that we can get this distance. So that will just be 3.5 minus 3.2, that will be 0.3. Okay, and its rotation about point O will also be clockwise, right? So it will be positive here. Now for the 60-pound force, okay, so its moment arm about point O will be 3.2. Okay, and its rotation about point O will be negative. That's why it will be negative here. 60 times 3.2 now. Okay, so from here we can solve for the value of distance D. Okay, so this will be 18 times 8.3 plus 30 times 4.8 plus 46 times 0.3 minus 60 times 3.2. Okay, so divided by 154, that will be 0.74805 inch to, no? So this is inch. So our dimensions here are inches, no? Okay, so that will be our distance D. Now, since we have distance D, okay, so our goal here, class, is transfer this resultant R to point O. So transferring this 154 pound to point O. So let's say we transfer it here. Okay, so since we transfer it here, we have to add here a force that is opposite in direction, okay, and also equal in magnitude. So we will add 154 pound here. Now, this 154 pound force that we have added and this original position and original 154 pound force here, so it will produce a couple. So the produced couple here will be what will be this direction? It will be clockwise, right? So after transferring this 150 pound force, so there will be a produced couple here, and that couple will be clockwise. And the magnitude of that couple will just be C is equal to F times D, wherein F will be 154 pound, and the distance D will be this distance D that we have solved. So solving for the magnitude of the couple, it will just be 154 times 0.74805 inch. Okay, so solving for this, it will be again 154 times 0.74805. So that will be 115.20 pound inch. So this will be the couple that we are looking for, no, for the equivalent system. Okay, so redrawing our system to its equivalent system, wherein that system is a force, okay, and a couple, wherein the force is acting at point O, we can redraw it this way. Okay, so this will be the transferred equivalent force, okay, at point O, and this will be the couple. Okay, so this will be the system that we are looking for. So this will be the answers. This drawing, okay, so the couple, the value of the couple, and the value of our resultant R. So this will be the answers for this problem. So that concludes our discussion. So I hope that you learn. And reminder that you have to answer the course material assessment task for this topic, and it will be submitted the following meeting. So see you again next meeting class. Bye-bye. Keep safe. God bless.